Okay, we're here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities, and we are looking at 8.1. Okay, find the solution set, write an interval notation. So let's go ahead and write this one down, and get that out of the way. 20x minus 28 is greater than negative 6. Alright. So we got the absolute value, 20x minus 28 is greater than negative 6. Alright. Now, remember that no matter what we plug in here, okay, the whole output is going to be either greater than or equal to 0. Right? We can fix a number that we can plug in here to get 0, or anything greater than 0. I mean, that's what the absolute value is all about. So, we got this thing greater than negative 6. So it's like no matter what we plug into here, it's going to always be greater than negative 6. So I want you to think about that. Okay? But we're going to go ahead and go through the algebraic steps of like we've been doing and see what we arrive at. Okay, so we drop the absolute value bars and then go ahead and solve for x. Now remember, this is pointing to the right. Okay, it's pointing to the right, and that means or. Alright, so we've got to keep that in mind. And go ahead and rewrite over here, 20x minus 28. This time we're going to flip. Right, multiply that by a negative, so that becomes positive 6. So let's go ahead and solve for x over here. And so we have 20x is greater than, and what is that, 22? Right, 28 minus 6 is 22. Okay. And so now we have x is greater than 22 over 20, and of course that's going to reduce down to 11 tenths. So x is greater than 11 tenths. Alright. So these kind of problems are designed on a test to basically take your time up if you don't know what you're doing, because you should know exactly what the answer is without having to write all this stuff out. Okay? What that interval is. But this is just to make sure that do you really know what you're doing, what's actually going on here. So they put stuff like this on a test, and this is to use your time up, so be careful out there. Right. So we got 20x is less than, them teachers can be tricky. Alright, and so we have 28 plus 6, which is 34. So we have 20x is less than 34, and so x is less than 34 over 20, and of course that's going to reduce down to 17 over 10, less than 17 over 10. Now I'm just going to get a little approximation going on here so we kind of know where these guys are at on the number line. And of course this is going to be slightly bigger than 1 there. Right, 1.1 kind of just helps us see where we're at on the number line a little better, I think. So we're going to scribble out our number line here, and let's go ahead, look at this one here. X is less than 1.7. First off, let's just go ahead and put 0 right here. Okay, so we're going to say this is 1.7, and or 17 over 10 I should say, and x is less than that. So let's put a open circle and everything going in that direction, right? Means that x is less than 1.7 I mean. And now this one here, x is greater than 1.1. I don't know, we'll put it right here, what the heck. And then so this is 1.1, here we'll put it down here. X is greater than, so that's going to be everything going off in that direction. Everything going off in that direction. Now remember, this is pointing to the right. So think of that as an OR statement. Okay. So that means that you can pick a number, choose a number, right, anywhere to the left or anywhere to the right. And what's kind of funny about the OR statement is somewhere hidden in that OR statement is an AND statement. Because this guy right here, if you picked a number in here, this would be in both. Satisfy this and this right here, right? So that's kind of the funny thing about the OR statement is it can be this or that or both. Okay, or both. Okay, so we're going to go, so what we really want to do here is just say, look, right, from negative infinity to positive infinity. Because if you were to go ahead and write this out, this would be negative infinity 17 over 10 and union, and then of course 11 over 10 to infinity. But that's kind of silly because what does this mean? It just means this, right? It just means that, since they're overlapping as they pass each other somewhere right in here. Okay? Right, negative infinity to positive infinity, bam, you should be able to look at that problem and see it immediately. If you don't really understand what's going on here. Okay? Alright, there you go. Okay, so we are somewhere. We're over here, go to math.com. Come on, practice. See you later.